Hi, everyone. Thanks for joining us on Analytic Stories. I'm super pleased to have Kaiser Fung with us today. And thanks so much for being here.
Well, thanks. I'm happy to show up on your channel. I've been a big fan of your work for a while.
Excellent. And likewise. So we can be mutual admirers today. So let me just tell you a little bit about Kaiser, because he's really got not only a great background, but he's just doing some really interesting things in the space that we're all interested in. He earns his money through being a consultant mainly, and his areas of specialty are data science, advanced analytics, and data communication. So it's kind of like the holy trifecta in our space. And he's been building teams at various companies like SiriusXM and Vimeo, where I am a customer, and really helping them through data to build their growth. But he's also been involved on kind of the other side, which is the digital marketing. So kind of externalizing those ideas and really working on things like performance dashboards, marketing attribution, segmentation, scoring models, A/B testing, really advanced kind of thinking in using data well beyond just saying, hey, I've got to get some reports and dashboards out, things like that. He also worked at a really interesting startup called X+1, which I followed for a while. And they were really starting out in looking at machine learning and how that would use that kind of technology for ad exchanges and placing ads. So we have Kaiser, I think, to thank for all those ads, that come up in front of us. But anyway, he's also, this is the area where I think is really interesting that comes into his education background, because he's got degrees from Harvard and Cambridge and Princeton. And that's really built on that kind of data science foundation, which has led him to be published very widely. But also, he's written a couple of books. And he's also created this amazing blog called Junk Charts. If you haven't seen it, you should definitely check it out. It's one that I like quite a bit. And he's also taught at NYU and Columbia. And again, he runs boot camps and does that for corporations. So you should definitely check out a lot of the work that he's done. So anyway, having said all that, Kaiser, again, thanks so much for being here.
Yeah, I'm looking forward to our discussion. I think it's going to, we may have some fireworks.
Well, let's not blow any fingers off. Well, if all goes well, we're supposed to be able to get together for the 4th of July, right? According to the president. So we will have a chance for some real fireworks. But anyway, let's get into the meat of this. So, one thing I've seen you do over the last year is write a lot about COVID and how data is being handled. And obviously, we've all seen that quite a bit, and it's really pushed data into the forefront of everybody across the world, really. And you've been doing some really interesting analysis on your blog, Junk Charts, with respect to some of that data. So I'm curious, you've really dug into this. So from the things that you've seen, is there anything in particular that has stood out as like a common thread of a bad practice that people are doing in all of that kind of analysis and presentation? And why do you think that it's happening?
Yeah, so in the last few months, I've written a lot about the scientific studies behind vaccines. Mm-hmm. Firstly, we had a lot of data coming out of the randomized clinical trials from Pfizer, from Moderna, AstraZeneca, Oxford, J&J, and now we have all these real-world studies that have appeared. But I think that the worst practice right now is that the media tends to focus on that shiny object that we call the vaccine effectiveness, and they ignore how each of these research teams actually compute the number. So, for example, a vaccine efficacy number that comes from an experiment, a randomized clinical trial, has a very different status in the view of statistics and data analysis than a vaccine effectiveness number that comes from just comparing people who have been vaccinated with people who have not been vaccinated in an observational study. There's also the problem where even within the randomized clinical trial world, the FDA has allowed every pharmaceutical company to define its own way of defining what's a case, of deciding when to count cases. And so none of those numbers are really directly comparable to each other. And I think that's actually one of the worst practices, because now it's kind of like in the business world, right? We say you need one source of truth.
Yeah.
One source of truth here.
Always, that's everybody.
Everybody is computing their numbers in a different way. And it's like the Wild West. And the media are not differentiating between them. So a lot of what I do in the blog is to provide people some nuance so that they can actually interpret all these numbers properly.
I think that's that's a big problem in general. I think even with COVID, when they were even just publishing basic numbers and saying, what certain rates were, or rolling day averages, 7-day averages, things like that, and using terminology that wasn't even common to most people, that they would understand what that meant, which is like, is it going up? Is it going down? Is it safe? Is it not safe? But the problem you're bringing up is really interesting, because as you were starting to get to, is it happens all the time in business, right? Where people within a company compute things in different ways because they just do. They're just setting stuff loose, right? And I think it's becoming a bigger problem the more access that people have to data, right? Because it was more centrally controlled in the past, right? You would have like an IT group, and they would have control everything that kind of happened around the data. And now with the new applications, right, that have come out over the last decade, anybody like me, I don't know how to code, but I can get into all the data pretty easily, right? Push a couple buttons in the software, and now I'm in, and I can do whatever I want. And if there's nobody guiding me, right,
there are some direct parallels, right? A great example is like in the marketing attribution world, right? So there's always an attribution window, oftentimes baked into the software, but there are always arguments over it, right? Should you be counting actions that took place within 3 days, 5 days, 7 days of some kind of the ad or the email that you send, things of that sort. And if you choose different counting windows, you end up with very different views of whether the campaign was successful or not. And funny enough, that's exactly what the farmers are actually doing right now, because they all have their own way of, well, I'm only going to count cases that happens after 7 days or 14 days or 21 days, or everybody does a different thing. And, obviously, they choose the thing that makes their product best. And it's exactly the same types of things that I used to have opinions on when I was working in the business world. It's like, everybody has to standardize, right? I mean, it's not, we can debate over what's the right number of days, but I think that the reality is you want one source of truth. You want everybody to conform to the same counting window, which unfortunately has not taken place yet. The FDA has not it's not telling the pharmaceuticals that they have to conform to one source of truth.
It's kind of frightening in a way to think that this is going on. So how do you, if you translate that over to the kind of the business world, and like you said, people want this one source of truth, how do people get to that? So if there's either people who are just deciding to do their own thing, right, because they don't know any better, or there's just these disagreements, what are some things that people can do to try to reduce the risk of something like this. Because like you said, if people are computing the values in different ways and you're trying to make real world business decisions, whether it's something about the vaccine or some marketing plan, whatever, you still have the same kind of issues of you don't want to make the wrong choice because the data wasn't, kind of aligned the right way.
Yeah, I think one common solution is to have a centralized center of excellence for data analytics, or some kind of centralized analytics team that would, obviously you would consult widely with all the different business teams, all the teams that utilizes metrics, and the goal is to try to get a consensus that everyone can agree on a particular way of looking at things. And then if you have the executive support, then they're not going to want to look at any other numbers other than the ones that are computed based on the consensus definitions. And you have to work hard at it. But that typically is the way that happens. Because if you don't have that one view, you end up wasting a lot of time arguing over how you count things as opposed to what the actual business condition is.
Yeah, I think something like that. It's you have to get to some point where you can agree to disagree, but you have to pick at some point. But it's interesting. I like that idea of that center of excellence, which of course is not a new term, but I think the way you think you're proposing it is different from a lot of what I've certainly seen, where a lot of companies have a center of excellence, but usually it's like around some technology, right? We need a center of excellence for Tableau or Power BI, or, it's not around that kind of thinking. It's usually much looser, and it's more like something around user bases in the company, not around organizing that. Maybe that would fall under like a data governance team or something, but
yeah, I would say
loose.
That's exactly when you were talking about that, that's exactly my train of thought, right? The center of excellence is not just about defining metrics, but that's an important part of the work. But also, data governance, privacy, security of data, all of that, even data quality, right? So how you process data, I think, is also important, because what happens is if you don't do a centralized processing, and if each division does its own processing, right? Even just things as mundane as like dividing customers into age groups, you could end up with incompatible groups that, right? So there are lots of things that the centralized team can be leading that could simplify the lives of a lot of people.
Yeah, that makes sense. And I think that a lot of that activity, even if companies are doing it, it is more siloed in that different groups have decided to take those efforts on, when probably there's some level of coordination, because it should be more strategic in those things, right? It shouldn't just be, let's operationalize data governance or security, right? Because there's probably links across those. And I have a feeling that most places right now, those are just separate activities. We need security, we need governance, we need data quality, all those things you listed. So I think that's a challenge, which actually leads me into another question I wanted to ask you about. So actually, it's a good segue, because part of what you do, which is, I think, a very interesting specialty, is working with companies and helping them kind of figure out, what is this data science thing, right? And helping them with, figuring out how to introduce data science into the company in different ways. And I don't think there's a lot of people doing that. And so part of your work, you're getting into things like data processing and statistics. And even for people like me, some of that is pretty new. Like I'm not a stats guy, right? So I could picture myself in here. So you're trying to expose people to these new areas. And like everything, when you get exposed to something new, there's like a level of discomfort because you're not really sure how you're going to do it or how it fits into your job. So can you talk about how, what's going on in that area, like what you're doing and kind of how you're seeing people handle working with these new ideas?
Yeah, so I think we have yet to really figure out what's the best way to teach people data skill sets. I think a lot of what was tried and true in academia isn't really going to translate well. So if you think about, like if I think back to my education, when I was taking math classes, engineering classes, even stats classes, those are oftentimes very problem set driven courses. And in every class like that, you are assigned some problems and then you have answer keys. You go to the back of the book, you look up the answer. That tells you that it's a very formula-driven instruction, that there's a presumption that there's a correct answer to every question. But the biggest challenges for training data analysts is that you have to accept that we are in a world of uncertainty and incompleteness, right? So we don't always have the data that we need to answer the question, and the data that we're given may be wrong. So most classes, I think in college, are not training people to figure those things out. They are training people to take the data they've been given and find the right formulas to get to a correct answer.
Yeah, so interesting.
So I think that's a big challenge in how do you get people to jump out of that mindset and kind of get into a different mindset. Because statistics, while it is often considered to be a branch of mathematics, it's really not your typical like pure math. It's a very different field.
So talk a little bit about that, because I think that this is this issue about statistics is important because it's going to play a big role. I mean, it plays a big role, but I think it's going to filter down to the everyday person at some point. It's not just going to be the realm of pure data scientists. And
I mean, like in pure math, the whole goal is to try to prove some theorem. You're taught to figure out how to prove some general theorem, and the idea is that the theorem has to apply to every single case.
Okay,
that's the opposite of what happens in the data world, because you will never find any equation that would apply to every case. That's right. Just impossible, right? The point is that the data has noise and there's uncertainty. So you kind of have to have a different mindset. The same thing is like the opposite of this is in pure math. Counterexample is extremely important. That's because if you find one counterexample, you've disproven the whole theorem, right? That's the answer.
Right. Yep.
In statistics, I don't care about your counterexamples. I'll probably treat them as there are a few outliers, but in the general case, on the average case, I'm still correct, right? So we're really talking about this sort of being trapped in a very deterministic type of thinking, and how do you get yourself to go outside of that, right? It's oftentimes we're not talking about right or wrong as some kind of a binary thing in statistics. We're only concerned about the probability of being right. And that's a very that's a very different mindset. And I think that's really, really important for anybody getting into this field to recognize.
That's interesting. Right. It's not that it's necessarily right or wrong. There's a level of rightness or wrongness to it, which is also people want to know if it's just right. Is it the answer or not the answer? And how do you level it? So how do you think this is going to be something that we can get comfortable with? What is it that, just again, kind of typical business user like myself, has to get into my head, like about this? How do I start?
Yeah, I see sort of statistics and kind of the whole data science as sort of a way of thinking, right? It's almost like it's the confidence that you need to have in applying kind of this type of way of thinking onto data. It will arrive at certain answers, and then the communications part comes in, right? So then you have to be able to explain to people how you get there, why this conclusion makes sense, with obviously the condition that you could be wrong, right? I mean, there's certain situations under which you could be wrong. And a framework that I oftentimes use is that I would be very careful in thinking about under what assumptions would my answer be correct. And so then it focuses the problem on how believable those assumptions are. And sometimes you may be able to gather further data to validate those assumptions, and sometimes you can't. It may not even be possible. But being very clear about what assumptions you have made in order to get to those conclusions is really it's really key.
Yeah, I like that. I think so. I think that assumption is a different way of thinking about things, because we always think, okay, we have the data and the count is 5, but we don't necessarily think about, is 5 absolute? Are we really sure about 5? And maybe we are, but are there conditions where maybe that 5 might be wrong? And I know I'm probably simplifying it down way too much, but it's giving people, it's training people in another way of thinking about things, I think, is, what I'm hearing, which is not necessarily training them on the formulas or necessarily all the techniques behind it, but the thinking around it, because not only the thinking that goes into figuring out what you're learning from it, but also then being able to explain it back, right, in a way that can drive that ultimate decision making.
Yeah. I can give you sort of a concrete example from some of the stuff that I've been writing about COVID. So currently there are a lot of real world studies, which means that we don't have an experiment. So they're just comparing people who are vaccinated with people who are unvaccinated. And there are different levels of sophistication in these studies. Some of them are very unsophisticated. I was recently shown a study where they just took people who are healthcare workers, and all they did was to compare the people who've been vaccinated with the people who've been unvaccinated. And they say that people who've been vaccinated have had a much lower case rate than ones that have not. Now, if you use sort of the framework that I've been using, then the question that you're asking is, under what assumption would that be correct, right? So a statistician would immediately reject that analysis by saying that, well, that you can't really do that because you're not comparing apples to oranges, because these people were not randomized into being vaccinated or not. So that's one way of thinking about it. That leads to essentially a rejection of the analysis. But I like to phrase this as, well, that analysis could be correct, but it would be correct under the assumption that the vaccinated people are just like the unvaccinated people. The only difference between them is that they got the vaccination. Now, but if you phrase it that way, then you can go explore this, right? Then your next question to ask is, can we look at the characteristics of the two?
Right. Are they the same?
Actually, it's the same. And of course, if you do look at that, it's clearly not, right? So the people who are vaccinated typically are older. They are maybe have larger families, more people to protect, and things of that sort, right? So then that creates a much more, I think, useful way of thinking about the world than a world in which you just say things like, oh, correlation is not causation. I mean, this is basically the same thing, right? Compare vaccinated and unvaccinated is just a correlation because there could be many different reasons to explain that difference. So I don't like to just say correlation is not causation, therefore throw out the analysis. I like to say correlation is sometimes causation, sometimes not, depending on what you can assume.
Right.
So you just have to validate whether those assumptions hold or not.
I like that. I think that could open up a lot of doors to introducing some of these ideas into the mix, where right now it's still, it's a lot of, I don't want to say, it's very magical to people like me, right? It's like it's done, and the answers come out somehow. So let me bring this to a close, because I think one of the ideas I wanted to poke around with was, imagine that you could get every data practitioner together, right? All these people we've been talking about, everybody in the world will just go big, and you create this one massive online class. Everybody's going to come to this. Let's say it's just for an hour. So what would you teach them? Of the things we've talked about, what would you try to teach them in that hour, and why do you think it's so important to their future to learn that?
I have thought about that quite a bit. And in fact, I had a course that was out there for a little while, some years ago. It wasn't 1 hour. I think your target is it's even more ambitious. It was more like a 3-day course that maybe had like 9 hours of materials in it. And the class was titled "How to Do Statistics Without Math."
Okay.
And that's really what I think for a course like that, what it should focus on. Because I really do think statistics is a way of thinking. I think that you can reason using statistical concepts without having to learn math first. Of course, if you're wanting to be a serious data analyst, you eventually need to know math and coding and other types of things. But for most people, you can use these concepts without really applying formulas. And in many ways, that's sort of what I was trying to accomplish when I wrote my 2 books, right? Numbers Rule Your World and Number Sense. Because they just get pretty deep into statistical thinking, but there's not a single equation or a formula or anything. I don't even tell people how things are done. But it's just to develop their intuition. So for example, if there was a chapter in there which happens to be quite something, it's about investigation of disease outbreaks. So it's pretty relevant, right? So if you had read the book before the pandemic, you would already have learned a number of the major discussions we ended up having, the debates that we ended up having last year. Because you're going to find out that at the beginning, in January and February, there would have been very few cases, and it would have been very, very difficult for the government to decide whether this is going to develop into something really huge, or is this going to be something that would just be a pop and then go away. And that is a dynamic that happens with every disease outbreak. and so that people would have learned about that, right? So I also have pointed out that we are potentially, as we said at the beginning, we may have fireworks by July 4th. We're potentially nearing the end of the outbreak. Now, it's going to be very interesting at the end, once it goes away, whether we're going to attribute it to something like, well, it's the success of the vaccination campaign. Or it could just be that the virus has slipped away. Because a lot of disease outbreaks eventually will naturally die away without even human intervention. So, but that too is a very difficult thing to decide on, because again, you don't have an experiment, you have things that are correlated in time, and you just do not. It's really hard to know.
Right. You're not just going to wait forever to see if it goes away.
Well, I mean, I'm talking about assuming, looking backwards, like once they've gone away, and we wanted to know why it went away. That it would be a pretty difficult statistical data problem for somebody to look into. So what you find is that learning in statistics is oftentimes by finding sort of commonalities between different problems and different anecdotes of things that have happened in the past, and kind of tying, it's sort of like the proverbial being able to find patterns, right? So this is sort of an example of finding patterns between, similar types but different instances of things. So I think I'll definitely leave you with that, right? So I'm a big believer that everybody can pick up some data reasoning skills, even if you don't want to learn all the math. In this world where we inundate with data, it's really, really important for people to get there. So that would be my 1 hour class if ever comes to fruition.
I like that. I like that, because I think I know you wanted something that was, say, a few days long, but even if you could pique people's interest, right, and start to bring some of the people along, not necessarily everybody, but if that was enough to convince people to maybe go to the next step and say, oh, I didn't realize I could do all this without having to get into the math and be scared of that side of it, that you start to have some people who say, great, I'll go the next step and I'll really start to learn this, right? So the hour may not be obviously get you to the end, but draw you in. Because I mean, even just what you've said during this 30 minutes has been really eye-opening for me, because that's how I always think of statistics, is frightening, and you see equations with exponentials and all kinds of math behind it. And I used to do all that math, but it's been a long time, so I don't really want to necessarily go back to it from the school days. But I think that's a really interesting concept to promote, because I think if you can find a way to deliver that, right, and it sounds like you've been thinking about it for a while and had it, if that can be something you can kind of inject into people, I think it would be very successful for you from a business perspective, but successful for really helping companies get to that next level. So any final thoughts? I think we're about ready to close out. Anything else you want to share?
Just to highlight what you just said, right? Most of us who drive cars, we do not know how to put a car together. We wouldn't know a thing about why the car runs, but we can run it, right? So I think that, to me, is like, for a lot of people, you should be able to reason with data, even if you don't know how the sausage factory behind how the math works.
That's awesome. Yeah, I really like that analogy. That I think that's true with almost everything, right? We can use it, but we don't necessarily know how the innards work. but somehow we're still able to do a lot with it. So yeah, that's a great way to think about it. So, well, you and I will talk some more offline about this idea, I think. So, Kaiser, thanks so much again. We covered a lot of interesting ground in a short time, and I'm sure we've got our listeners thinking, and hopefully some of them are starting to move towards, hey, I think I should get more involved with statistics, but I can do it in a way that I don't have to open up a math book or start to write code in any kind of detail necessarily. So appreciate your time, and everybody, thank you again for joining us. Check out our other interviews with great folks like Kaiser that are on the YouTube channel. See you soon.
Right. Thank you. Goodbye.